Having defined the linearity measures, now we'll consider ways to estimate IIP3. So now from the graph, it is very clear how to find IIP3 for LNA. Now we have to go for ways how we can estimate IIP3 for an amplifier. Even though in manufacturers give everything in the data sheet, it is best when you have the amplifier in hand, it is best practice to estimate what is the value of IIP3 which the amplifier is going to possess. So that will give an idea for you when you're going to decide use the amplifier for other applications. So one way is to simulate. You have a lot of softwares available, MATLAB, PSpice. So one way to simulate, so send two sinusoidal input signals to your amplifier, find the spectrum. Spectrum is measuring the frequency versus power. So plot the spectrum frequency versus power. You will have lot of frequencies. Fundamental frequency will have a lot of power. Then the subsequent harmonics will have lesser power. From this, you can find out what is the third order intercept point. So from the third order products, you can find out what is going to be the IIP3 point. First step is simulation. So using simulation, you can find what is the IIP3 product. That is what is the first method is given here. Although it is simple, all the practical constraints will not be considered here. So you will consider the amplifier to be ideal. So we'll estimate IP3, whatever we get from simulations might not match when you estimate the IP3 in the actual practice. And also in simulation, we will not include the parameters of noise. We will not expose the system to all possible environments. So there are several types of noises we have learned, right? So each one is going to change the value of IP3. So simulation is going to be very simple, where you can get a blind estimate of IP3, but that will not be the good method because the amplifier will not be subjected to all the types of non-linearities, and hence it will be just a new number, but you cannot straightforwardly go with the design of the IP3, whatever you get from simulations. So again, we are going to go for a mathematical method to estimate the IP3 for an amplifier, and this method is called as a three-point method. Again, three-point method, we are going to consider till the third order IP3. Five-point method is also there, where we'll consider till C4 V cube and C5 V power 5. Okay, so more number of points you take, you will get the value of IP3 more accurately. That is the understanding. So I'm going to derive the IP3 estimation using the three-point methods. This equation is known to us, the output current in terms of input voltage. And I'm going to derive a function in such a way that I'm going to assume this variation of my signal. So G of V is approximately equal to C1 plus 2 C2V plus 3 C3 into V square. So I'm going to assume this variation of my signal. So this is the actual output current from an amplifier, and this is the function which I'm going to try and map the I with respect to G. The actual I is there. Whatever G we are going to write for an amplifier is there. I'm going to match these two and find the coefficient C0, C1, C2, and C3 from these two equations. Although any three different values of V would suffice, we are going to take three possible voltages, 0, V, and minus V. So, 0 is going to be the ideal value, and V and minus V are going to be, when you consider sinusoidal, the peak to peak value, positive peak we have plus V, negative peak we have minus V, right? So instead of taking specific numerical values, I can take these three values for finding out the different bias conditions for the amplifier. So I'm going to take 0, V, and minus V. I'm substituting the same in G, and I'm getting the expressions here. G of 0 is C1 because all the other terms will go away. G of V is going to be the same thing, and G of minus V is going to be this thing. Only the middle term is going to be negative.